All right, hello everyone. I hope you're all doing well. We're back with another question, and this question comes from the IB Chemistry Paper 1 HL from the May 2018 Time Zone 1 batch. So in this question, they've asked us, what are the functional groups in the aspirin molecule? They've given us a diagram of the aspirin molecule, and then they've given us three options from which we have to identify which functional groups we can see in this molecule. So we have ethyl, carboxyl, and ester. And then obviously we'll have these four options from which we have to choose. Now, before we proceed with identifying, I want to first explain what each functional group is. So the ether functional group is basically this. This is pretty much it. And you can have two carbon molecules attached on either side of oxygen. And you can have something like this. And this is the functional group. This right over here is the functional group. Right? It really doesn't matter what is attached on either side of oxygen, but this is a functional group. You can think of it like a bridge, right? It's a bridge formed by oxygen between two different molecules or two same molecules. Doesn't really matter. This is an ether bond or an ether functional group. What about a carboxyl functional group? Well, carboxyl functional groups are found on carboxylic acids, and they constitute of a carbon, which is double bonded to an oxygen, and single bonded to another oxygen, which is then bonded to a hydrogen. So basically, this is a hydroxyl group, and then you have the double bonded oxygen. So this whole thing together is called a carboxyl functional group, and you find it on acids. So you'll find it on methanoic acid, ethanoic acid, propanoic acid, so on and so forth. You know the drill. What is an ester? Now, an ester is a functional group which is formed when a acid or a carboxylic acid reacts with an alcohol. So the condensation reaction between these two forms an ester functional group or an ester bond. Now, I'm going to show you how that looks like so that you don't get too confused. So I'm gonna draw it out over here. So example, you have ethanol. All right, you have ethanol. So you have this is an ethanol molecule, and then this reacts with an ethanoic acid. Now, esters are actually, a fun fact, ester is actually the substance which gives your perfumes that fruity or that nice smell. They are responsible for that, and that's one of their uses in industry. And that's also one of the applications of learning these reactions in chemistry. So if you ever end up working in the cosmetics or the fashion industry, you know how to create a specific fragrance. Anyways, so as we all know, a condensation reaction occurs with the removal of water. So in this case, you probably identify water is removed from here. So you have one hydrogen. So you have the hydrogen from the carboxyl group, and it combines with the hydroxyl group of the alcohol to form water. So we remove this, and then this oxygen over here extends itself and forms a bond like this. And then you have the removal of water. Now, you may be a bit confused between the ether and ester bond because look, it's the exact same thing, right? You may think that, but the difference is that this alone is not the functional group. This is alone not the ester functional group. The ester functional group actually constitutes of this. This is the ester functional group. So the ester functional group is actually COO. This is the COO. It's the COO group. COO, only not COO, it's COO functional group, like the sound the birds make. So this is the functional group for esters, whereas ethers have a functional group of this, whereas the ether functional group constitutes of this. So that is the difference between an ether and an ester functional group. Now let's identify what functional groups are present. Oh, oops, so sorry. Let's identify what functional groups are present in this aspirin molecule over here. So, well, just off the bat, if you have noticed, we can see clearly that there is a carboxyl functional group. We see it, right? We see it over here. There's a C which is double bonded to an oxygen, and then the C which is attached where there's a hydroxyl group attached to the carbon. So carboxyl group is there. We can eliminate B because that doesn't include carboxyl. And then what about ether? Do we see an ether group? Oh, you may look at this and say it's an ether, but then you would be wrong. That's not an ether group. Look at this. It's a Cu group, just a Cu group. So that's not an ether. That's actually an ester, and this is formed by the condensation reaction between a where it appears to be ethanoic acid and an alcohol. So the correct answer for this is C, because that's 2 and 3. And this is also the right answer. And hopefully you have understood these three important functional groups, and now you're prepared to tackle any question which involves these functional groups, or whether you have to draw these or something else. Thank you so much for watching. Hopefully I have managed to clear any doubts you may have had. If you have any other questions regarding this concept or any other, please feel free to reach out to me on my social media, or send me an email, or put it down in the comments below. I'll be more than happy to help you. Thank you for watching. Take care, everyone, and I'll see you in another video with another question.